pairs tables, we even looked at functions graphically. Now it's time to get into equations with functions. And we use these function notations a lot in word problems. Now, here's the function notation. This is the general form of it, where you have y being your output, which is also the dependent variable. Here you have f, which is the name of your function, and you have x being your input or independent variable. And f is just a common name we use to represent a function. H and g are also popular, but f is just common. Okay, again, just like we did in the first video, we wanted to get a sense of what a function was through the real world example. Let's go ahead and do another real world example with function notation. So let's say I'm in a car, I'm at rest, and then I start to accelerate. So the variables we'd want to use in this case would be t for time, and then s for my speed. So let's say I came up with the equation s equals t squared. From that, we could tell that t would be your independent variable or your input, and s would be your output or dependent variable. Because I know that my speed would depend on how much time has passed by, because after I accelerate, I'm going to go faster and faster. So my speed would depend on the time after my takeoff. Now let's say I wanted to put this in function notation. If we want to match this up with the function notation, we would write our dependent variable first, which is s. We would have to call that function something, but I'm just going to go ahead and call it f again, which is something, common name we use for functions. And then I would have to put my input variable here, which is a t in this case. So if I wanted to represent my equation in function notation, it would look like this. Since s is equal to f of t, I could replace this s here with f of t and write it like that, which is a more common way that you see it written. So we have f of t equals t squared, and by the way, that is how you would read this, f of t. So what that's letting me know is that f is a function of t, so all I would expect on the right side of this equation would be t variables, no other variables other than t to appear. We could have constants and stuff like that, but mainly I'm just expecting some t variables on this side. And if you don't want to keep using the generic name of a function to be f of t, we could write this as s of t equals t squared to stay in the context of our problem. Okay, so let's look back at our balance equation that we worked with earlier. Looking at the ordered pair, we could see that b is the dependent variable, x is the independent variable. So we know that b depends on x, so b is a function of x. So let me write that. B is a function of x. So now if we want to put that into function notation, we could put it as b of x is equal to 2000 minus 400x. Again, it's crucial to notice that this parentheses here does not mean multiplication. It just simply lets us know that b is a function of x, and the way we would say that is b of x. Now, let's say we actually want to use this new notation and see what the balance would be after 2 months. The way we did that previously was we just simply put a 2 into here, which was 400 times 2, which is 800, and then 2000 minus 800 would be 1200. So the ordered pair that we got out of this was 2 comma 1200. Okay, let's try it now with our function notation. So if I want to evaluate what happens after 2 months, instead of x here, which represents my months, I would put 2, because I want to see what happens after 2 months. So this would be 2000 minus 400. And now everywhere I see an x, I'm going to replace that with a 2. So here I only have just one x variable. And there we go. And we already know what the computation is going to come out to be since we did it earlier in the video. It's going to be 1200. But the way now that this would look is we still put in a 2 for the input, but the output that we got was b of 2. and we know that b of 2 is equal to 1200 as before. It's just this is the new notation that we use now for it. Okay, 2 comma b of 2, and since we know that b of 2 is equal to 1200, this is still the same, b comma 1200. So you still get the same answer, the same ordered pair, it's just we're trying to use this new function notation to evaluate our inputs. Okay, if you found the function notation to be easy to understand, great. If not, we're going to do a bunch of examples, so hopefully we get a better understanding of it. So here we have a function, s of t equals t squared plus 2, and they want us to evaluate the following: s of 2, s of 4, and s of 0. So before I attempt this, why don't you guys go ahead and try this and give it a shot. Go ahead and pause it and whatnot, and then come back. Okay, so s of 2, they replaced the t with a 2, so that's what I'm going to go ahead and do. Replace every t I see on the right side of the equation with a 2 now. So s of 2 is equal to 2 squared plus 2. We know that 2 squared is 4, plus 2 is 6. So the corresponding ordered pair would be, when I input a 2 into my function, I get an output of 6. Okay, moving right along for s of 4, I'm going to do the exact same thing. I'm going to replace this t with a 4 now. So s of 4 is equal to 4 squared plus 2. We know that 4 squared is 16, plus 2 is 18. So now we know the corresponding ordered pair would be 4 comma 18. And if you want to just go off the way that this notation is, we could write it like this: s of 2 equals 6. For the previous one, for this one, we could write that s of 4 equals 18. Okay, and now this last one, s of 0. Yeah, they just replaced the t with a 0, so everywhere I see a t, now I'm going to input a 0. So that would be 0 squared plus 2. We know that this is just going to be 0 still, right? So our final answer would still be 2. So for this last one, s of 0 would equal 2. Okay, just wanted to get a little bit of practice in. We'll do some more to get the feel of this function notation. Okay, so here's another function they gave us. B of x equals 2x squared minus x plus 1. And they want us to evaluate b of negative 1, b of number. Now this is something new, but we'll go over it. So why don't you guys go ahead and pause the video, give this a shot, and then we'll attempt it together. Okay, so b of negative 1, this is pretty similar to the previous example. So we're going to replace everywhere we see an x on the right side of the equation with a negative 1. So b of negative 1, that would equal 2 negative 1 squared minus a negative 1 plus 1. So b of negative 1 equals negative 1 squared would be a positive 1. Negative 1 times a negative, that would be a positive. So, and 2 times 1 would be 2. So we have 2 plus 1 plus another 1, so that's 3, 4, right? So that would be it for b of negative 1. When we input negative 1, we get an output of 4. So looking at this one now, it looks kind of weird, but if we just stick to what we've been doing, we're just going to replace this x here with a number, and everywhere we see an x on the right side of the equation, we're going to replace that with this symbol here. B of number would equal, I'm not going to touch the 2, I'm going to replace this x with that symbol. So it's going to be number squared minus, here's another x, so I'm going to replace that also with that symbol, and then plus 1. The point of this example was not to actually solve it, because you can't really solve this out. It was just to get used to the function notation and how we're just going to replace whatever is in here with the variables we have on the right side. So b of number would just equal this whole string of messy stuff on the right.